So in order to understand that, let's take the same thing that we have drawn over here and go one step further. So I have A0 running from 0 to 40, then I have B0 and I have C0. A1 I said can run again from 0 up to 40, but B1 can only start at 70 and then C1, okay, which goes on up to 100. So it looks as though in order to complete 2 iterations of this graph, I needed to basically take 100 time units, okay. The next question is, what about the third iteration? When can A3 start? Do I need to wait until 100 or can I run before that? So A3 could actually have started here, sorry, A2 not A3, right, starts at 70, goes on until time 110, okay. As soon as A2 completes, B2 can start, it would go on until time 130 and then C2 would complete at time 140, okay. What about A3? A3 can start after C1 and then I can have B3. So A3 would start at 100, end at 140, B3 would end at 160 and C3 would end at time 170, okay. Now what is this saying? The iteration period has become 170 divided by 4, because I have finished 4 iterations within 170 time units. Is this the best possible? Is this really the iteration period that I am targeting, right? Or is it possible, if I continue running this, will I see that things are actually improving even further? Let us give it a shot. Going by exactly the same procedure that I had earlier, after C2, so at this point I can now start running A4 up to time 180, B4 up to time 200 and C4 up to time 210, A5 up to time 210, B5 up to 230 and C5 up to 240, right. Now what is the iteration period? It is 240 divided by 6, right. So this is 40. This previous one, 170 divided by 4 is 42.5, okay. The original one, 100 divided by 2 is 50, okay. So you see that the iteration period is getting better and better, but does it mean that I need to essentially run for infinite number of iterations before I can say that I have got the iteration period to 35, or can I just look at it slightly differently, right, and say that what I actually have over here is this pattern, and I can then redraw it as, so this would be AI, this would be AI plus 1, BI, BI plus 1, CI, CI plus 1, right, which effectively means that what I have over here is the next such block of this that I can execute would start over here. The next one after that would start immediately after that, and so on, okay. So effectively what I have over here is, this is my initiation interval, right, the time between successive starts of this weird shape jigsaw puzzle that I have, right, and this initiation interval becomes equal to 70. So in other words, what it is saying is, every 70 time units I can initiate one new execution of this combined system, which will basically finish 2 iterations of my original data flow graph. What I have over here is, this structure is essentially something that we call an overlapped or overlapping schedule, because the second execution, the magenta one that I have drawn on the right side after the green, right, the second execution starts even before the first one has entirely completed. Okay. The magenta one can basically start and process part of the computation even before the green one has completed. They are completely valid in the sense that there are no violations of any scheduling constraints, right. And the way that I am going to do it is, I am going to end up having some functions corresponding to iteration 1 of the combined ABC unit overlapping with the previous iteration of the combined ABC unit. So effectively what I have done is, rather than trying to execute one shot saying okay, this is the best iteration that I can get for this particular module that I have, I am combining it into combining two groups of that ABC together, and I am able to find one overlapped schedule that is able to get the best possible throughput. Okay. Let us contrast this with what would have happened if I insisted on having a completely blocked schedule. That is precisely what we have over here, right. This is an example of what I would call a block or blocked schedule as opposed to an overlapped schedule, right. So it is not that it is actually blocking something, it is more that it is being executed as one block. So it is the meaning of the word block in the sense that it is one block of data rather than that it is blocking something else from happening. Okay. And effectively what it is saying over here is, this is one block of data that is being executed over here. The entire thing has to complete before the next iteration can start. If I insisted on a block schedule, this is what I get. I will take 100 time units according to this in order to complete both of the first 2 iterations. We can take this further. What if I had only what if I had 2 pieces of hardware, right? Is this the best that I could have done? So what we are seeing over here is, I am able to get a blocked schedule for this system that has an iteration period of 100 for 2 instances. So effectively an average iteration period of 50. If I insist on a blocked schedule, is this the best that can be done for this system?